from WCIA 3 Plus. With your host, Stu Ellis. This is From the Farm.
Hello again, and welcome to another edition of Down on the Farm. If you are watching this in the fall of the year, we want to provide you with a plan to raise a higher yielding soybean crop next year. And that's what this program is all about. The topic is soybean cyst nematodes, which are the biggest yield robber there is for soybean farmers. My guest today is University of Illinois nematologist Nathan Schroeder, and we're going to talk about SCN, what it is, particularly if you are not a farmer or soybean producer, what it does, and we'll talk a lot about that, and wind up with a plan for you to eradicate as many as possible of those SCN nematodes in your soybean field and boost your yield for next year. So, Nathan, it's good to see you again. I get a chance once in a while to visit, and the topic always seems to be soybean cyst nematode. You may do a lot of other things, but anyway, let's talk about SCN today. So that's your favorite topic, I think.
Sure. Yeah. So SCN, soybean cyst nematode, is a microscopic worm that it's below ground, so you don't see it like you would, let's say, weeds that are growing, and it doesn't really cause a lot of above ground symptoms.
That's a significant yield loss, and I think people would, if they knew it was happening, they might do something about it. But as you say, it's non-symptomatic for leaves, for stems, for the growth of the plant, and those little guys are working on the roots, and we just don't see it, and so it's out of sight, out of mind.
That's right. And I think another issue is that it has been around in Illinois for a while, for several decades now. Right. And there were big campaigns in the 1990s to talk about its importance. And I think farmers appropriately adopted strategies, including the use of genetic resistance to combat it. And one of the things, and it was very effective. One of the things that we're seeing is that the nematodes are starting to strike back. So.
Right, and we'll get to those in a minute. But you said that we started getting aware of these in the 90s. Where did it originate? It didn't come out of the sky like rain does.
No, probably not. There's still a little bit of debate. It was first found in the U.S. in the 1950s. And really spread with the spread of soybean production throughout the United States. And it actually continues to spread as more acres are going into soybean, let's say in the Dakotas and in Canada. So it has been in the U.S. for a while. Our best guess on its origins is somewhere in Asia, probably where soybeans originated.
And it didn't come in on seed, but probably in soil somehow. And when soybean plants were transferred from Asia, why they brought the soil, and those guys were attached to the roots, and they got planted, and it's just one of those things.
Yeah, there's still some debates over how it exactly got here. Some of the best guesses are when soybean production was first picking up in the U.S., we were bringing over rhizobium inoculum, so the bacterial symbiont to help with nitrogen fixing.
How did it get into my field from somewhere else? And so when we inoculated soybeans, I can remember doing that with a scoop shovel and a bunch of black stuff that I put on a truck full of soybean seed. Is that where I got it? And
it's hard to say. So anything that can move soil can move this nematode. They're very small. So it could be inoculum. It could be taking your combine from one field to the other. So it could be on your boots. So you walk through one field and you get those clods of mud on your boot. That can easily contain nematodes that you then transplant to another field or to your neighbor's field or your neighbor to your field.
Okay, we won't.
Yeah.
Let's not go there anymore.
Yeah.
But we don't want to point any fingers.
Well,
but it's
yeah. And nowadays, really, it is everywhere. I mean, in Illinois, that, when it was first appearing in Illinois, there was a lot of concern about spreading it, but nowadays it's so widely distributed that you're not worried about your neighbor spreading it because you probably already have it.
okay. Should we generally say it's probably in most every field?
It's in most every field in terms of a statewide distribution. I'm guessing we'll talk about this free SCN testing program.
We will.
And from that program, we have found many fields that have 0 counts. Now, a 0 count just means we didn't find it. That doesn't necessarily mean it's not there. But it's possible that there are fields without it. But I think the general assumption is that it's very widely distributed.
And it could be covering 90% of a field, but where you happen to take a soil sample, it may not be there. And so that's something that you want to make sure that you don't make a management decision on that one soil sample that just didn't have it because the rest of the field may be covered with it.
That's right. In a field, it typically has a very, very patchy distribution. You can take a soil probe into one spot and get one count and then move over a couple of feet and you'll get a very different count. So it's challenging to accurately assess numbers.
Okay, now we're going to get to that the sampling part of it here just in a moment. We'll continue on with this conversation on soybean cyst nematode with Nate Schroeder, the University of Illinois. And we'll be right back right after this. Don't go away. Been talking with Nate Schroeder, nematologist at the University of Illinois, about soil sampling and for soybean cyst nematode. As we talk about it, if you're watching this program, you can see some of the sampling techniques, and it's going to be with the help of Nathan Klichevsky, who had been on the University of Illinois staff as a plant pathologist, and he and I worked together putting this together several years ago. But as you look at that, we can see, everybody can see that he's out in a soybean field, and the sampling. Are you going to take it with a shovel? Are you going to take it with a soil probe, or what do we do? How do we best get the sample?
Well, ideally with a soil probe, what we tell people is if you have it, go out to a, let's say, 10-acre section of a field and take about 10 soil cores to a 6 to 12-inch depth. So 1-inch soil cores, take about a dozen of them. You can pool them all together, all those cores together from that 10-acre plot, pool them together in a bucket. You can mix them up and put them in one plastic bag to send for testing. If you don't have a soil core, you certainly can take a shovel and use that and use a modification of the same technique. So try to get a distribution from the field. Again, because we know that there's such a patchy distribution, in order to get a decent picture of what's in a given area, we really recommend trying to take multiple cores from that small section.
And there are some patterns that people can use, zigzag patterns, and then if you've got an odd-shaped field, you've got other patterns, and I think those are generally available if you just Googled soybean cyst nematode sampling patterns, and
That's
you'll
right.
probably get a number of them. Now, something that I think a lot of people are saying, well, I'm sampling this in my soybean field, but that field is going to be in corn next year. And that's should I do this? Should I go sample my cornfield this year, knowing that it's going to be in soybeans next year?
So really, you can sample anytime, and then your interpretation of the results may differ. So if you've just come out of soybeans this fall and you take samples, well, now you know that next year those numbers aren't going to cause an issue because you're planting corn, but it may give you an idea of what to do in the subsequent year when you're back in soybeans. Similarly, if you just had corn, you can also sample, and then that's going to give you an idea of what to expect and how to manage for the upcoming year.
Now, will those populations go down and up depending upon what's in that field?
They will go up and down. So certainly in soybeans, they tend to go up, and in
Right.
corn, they tend to go down. So soybean cyst nematode has a fairly limited host range. It really likes soybeans. There's some other legumes. There's some weeds that it will grow on. It will not infect corn. It will not infect wheat. So those years, it will tend to go down. It won't go down to zero, though. It has tricks in its biology to sort of go into hibernation and recognize when corn is being planted or a non-host is being planted. So you will get some die-off, but it certainly won't go down to zero during those corn years.
Okay. Now, the when people look at a soybean root, what are and they happen to pull one up, what are they going to see that they should really pay attention to?
It can be challenging, and especially as you get older and your vision gets a little worse. So if you dig up a soybean plant carefully during certain of the part of its growth, you might see these small sort of pearly white structures along the root system. And I think we do have a picture to show of that. Those are the adult females of the soybean cyst nematode. So they will start to develop. They are just visible to the naked eye. And again, as you get older, they become a little harder and harder to see. So in this image here, you can see all these little tiny white dots along those are the adult females. And you can see them with the bare eye. However, as those nematodes actually develop, they turn from a sort of pearly white color to a rusty brown color. And then if it's mixed in with soil particles, it becomes really impossible for even the most eagle-eyed observer to really see it.
Okay.
So it is possible to see, but it can be challenging. And so that's really why we recommend doing the soybean cyst nematode egg testing, which is going to be done with a microscope. We extract eggs from the soil in the lab, and it's going to be a little bit more definitive than trying to look for the adult females on the root system.
Okay. So the adult females are really potentially visible.
Yes.
Okay. And they're going to deposit eggs, or are they just going to kind of dissolve and the eggs are there, and then those eggs are going to hatch, and a little nematode that's sort of a very small fishworm is going to come out of it.
Yeah. So for the biologist in me, it's a really neat biology in that the female will actually deposit some of the eggs, lay some of the eggs outside of her body, but then she'll actually retain some of the eggs within her body. And actually, when she dies, her body will form this hard cyst-like structure, and that's why we get the name soybean cyst nematode. And within that cyst structure, which is effectively her corpse, you've got hundreds of eggs. And so that adult female's body is serving as like a protective covering for all these eggs that are inside that can hang out until the next soybean crop comes around. And then they're able to sense that, and they hatch, and then they infect and move towards the soybean and infect and cause damage. The cycle begins. So.
Golly.
Yeah. It's almost, when I teach students in class about this, I think some get grossed out, some think it's like science fiction, but it's just a really interesting biological phenomenon.
Okay. Now, when the eggs hatch, the worm, the small nematode, will then drill into the root, and that's his or her feed and food, and at that point, that's when the soybean starts going downhill.
Yeah, so that juvenile worm will burrow into the plant. It actually goes towards the vasculature, the piping of the root, and will set up a feeding site where it will just feed and basically suck nutrients away from the plant. So instead of going towards bean production, it's sending those nutrients towards worm production. And then, it develops and eventually will form either adult female or adult male, and you've got reproduction and production of new juveniles that can reinfect. So you can have multiple cycles within a growing season. The generation time is about 3 to 4 weeks. So you can have, depending on temperature, soil temperature, you can have multiple cycles within a growing season.
Okay, so that right there tells me, as a soybean producer, I need to do something.
Well, hopefully. Yeah, hopefully I've convinced you.
But why can't I go check with my ag retailer and find a nematicide, and I can spray it on the field and just kill them all?
Well, those don't really exist for soybeans. So, there are some what we consider more traditional nematicides, in furrow chemicals, but really there are none that are labeled for soybean cyst nematode. Where we find those is in the southern United States on things like tomatoes and strawberries and other plant parasitic nematodes. For soybean cyst nematode, there are some seed coat chemistries that companies are advertising, but the mainstays of control that we have available to us are rotation and resistance.
And I'm glad you introduced that. We'll talk about that right after this when we come back. We've talked about what soybean cyst nematode are, what they look like, what they do, and we're getting to the point of what can we do to prevent it or reduce the impact that they have. And of course, crop rotation is one thing, and as we put corn in there for 1 year, the population will go down. But the best really potential way to get rid of them is using genetics on soybean seed. And for years, farmers have been using seed with genetics, PI 88788 genetics, but it's wearing out, I guess.
Yeah, that's right. So the mainstay for genetic control has been this PI 88788, which is just a soybean variety that has been used to breed in with other varieties this resistance, and it works. It's effective. However, we've been using it for the past
decades,
20, 30 years, and the resistance was never foolproof. So there were always some nematodes that were able to infect and develop and reproduce on this. And what we've found is that, like any sort of thing you can think about, herbicide resistance or something like that, if you use the same control strategy, eventually the bad guys fight back. And that's the case here. And so we're seeing more and more SCN populations in Illinois and throughout the Midwest that are able to reproduce on this source of resistance, PI 88788.
Any other resistance genetics out there?
There are. So there is one called Peking. There's another one called 437654. One issue is that we still have the current state where 90+% of the commercial soybean varieties have that PI 88788 source of resistance. So if you were just going to pick a soybean variety randomly, it likely has resistance, and it's likely from that source.
Do all soybean varieties have some resistance?
No, there are a handful out there still that are considered susceptible. It's not many, but there are a few out there. Generally, most seed companies are selling varieties that have some source of resistance, but it is possible to find a few susceptible ones out there.
Okay, should I check with my seed salesman, or is there something on the bag or the box that's going to have an indication of resistance?
Most companies will test for that or know what the source of resistance is. If you go into the marketing, you go onto a seed company's website, most of them will list it in there in terms of the attributes of that seed, along with other things like maturity group. They'll say what the source of resistance is.
Okay. Now, before we wrap up our program, we want to talk about the testing. And so we have Illinois Soybean Association has made arrangements with the plant clinic. Tell me about that.
Right. So this is the third year of this program sponsored by the Illinois Soybean Association, where Illinois farmers can send in soil samples to the University of Illinois, and then we will run the testing for them. So we'll extract eggs. We will send that egg count number back to them along with general recommendations. And if you have a really low egg count, well, that's great, and that gives you peace of mind. If you have a high egg count, well, then and you're using a source of resistance, that may indicate that you have one of these populations that's able to reproduce on 88788. We can actually do a secondary greenhouse test to confirm that, but it indicates, okay, you might need to make some modifications to your management strategy.
Okay. Now, what is the process? We appreciate the Illinois Soybean Association doing this and funding it. What is the process? How do I send in a soil sample, and what do I need to do?
So you can email us at freescntesting@illinois.edu.
Ooh, free SCN testing at
illinois.edu.
Free SCN testing at illinois.edu, and that's an email.
That's an email.
Okay.
We also have an associated website with if you Google that, free SCN testing Illinois, you'll get to our website. And if you email us or you go to the website, you can find a submission form, and from that it'll also indicate how to soil sample. You'll collect the samples on the acreage that you want to test. You'll send that in to us. We will do the processing, and usually we can get those results back to you within 2 to 3 weeks, along with general recommendations. And again, it's a free program, so the cost to the grower is the time doing the sampling and sending it in.
All right. So we appreciate that, and we thank Dr. Nathan Schroeder, University of Illinois nematologist, for joining us today. And we hope that you, before you shut the machine shed door this year, get some soil samples, discover the severity of your SCN population, and start with some resistant seed next year, and make sure you get utilize that free SCN testing program to benefit you. Thanks to the Soybean Association. And thank you for joining us. I'm Stu Ellis.